topic is the regression. And after regression, we will discuss the classification as well. Okay. So before discussing the regression, suppose I'm giving you this example. You are having this X data points and this Y values. X data points can be anything, like you can have the COVID patients in the month of January 2001, in the month of February, then March, then April, and so on. And these are the number of patients. Number of patients. This is the month. You can say this is the month. Okay, of 2021, and these are the COVID number of patients. So we can see that there is a relationship between them, any kind of relationship. As the month is increasing, number of patients are also increasing. Yes or no?
Yes.
So we can say this one is an independent variable. This one is independent. It is not dependent on anything. And this you can say is the dependent variable. Dependent. One more example I can give you. You are having, suppose you are having the age and the height. Okay. So you are having age 1, 2, 3, 4, 5 up to 18, and then the height is increasing. Or either it can, for other data, it can decrease as well. So we can say this, there is some kind of relationship. Yes or no? So there is a so since it was a simpler problem, so the problem that I gave you is a simpler one, and we can see this, we can have a line that can fit our data. We can have a line that can fit our data, but there may be the case like this. Maybe you are having this kind of data. Maybe the number of COVID patients following this graph, maybe January, February, March, April, May. After May, it is start decreasing, June, July, August, then it is start increasing up, then it is decreasing. So the previous example that I gave you is the simplest one. So we can see a line, or you can say a 2D line can fit our data. But in the real scenario, the data is not as simple as given to us. The data is not as simple as given to us. Okay. So the process of fitting a function, to a set of data points is known as regression analysis. Now it is clear what I am trying to convince. The process of fitting a function to a set of data points, is known as regression. Example you can have, suppose you are having from year 2011, say 2021, this one, and the number of students going abroad for their masters. This kind of data you can also have. You can have the age and the height. You can have the number of COVID patients, and with the number of COVID patients with in each month. Clear? So we have data, some kind of data, and the process of fitting a function. That means using the dependent variable, we can predict the using the independent variable, we can predict the dependent variable. In case of COVID patients, we are having the months, and we can predict the number of patients. Okay. So if you saw news, in the news you have heard that some professor from IIT Kanpur, or some professor from Chennai Mathematical Institute, or some professor from ISI Kolkata predicted that the third wave will arrive in March or March, April in 2022. How? Based on their mathematical calculation, they have the previous data, not only for India, they have the previous data of whole the world, and they design their mathematical model to predict the future COVID patients. Clear? So this is just an example of linear regression analysis. The definition is clear.
Yes, sir.
Instead of learning the definition, you can you can visualize in your mind. You are having some kind of data, and you need to fit a function to this set of data points. Clear? I will tell you in the detail the what are the varieties of regression and how you will going to do this fitting a function. So that definition is clear. Can I move further?
Yes, sir.
Yes, sir.
Okay. Tick. So now different books have their own way to write the definition, so I can dictate them as well. So the regression analysis is the process of estimating relationship between dependent variable for our COVID patient. Dependent variable was the number of patients. Independent variable was the month. For the students going abroad, dependent variable was the number of students, and independent variable was the year. That means in which in a particular year, how many students are going abroad for their higher studies. So this is a relationship between dependent and independent variable. See here, what is written here? Not variable, it is written here variables. Okay? And the example I gave you is just for only the one variable. Are you getting my point? The example I gave you is only for the one variable, but you can have more than one variable as well. Okay? So it is a relationship. We need to estimate the relationship between the dependent and independent variables. Clear? Depend on the number of variables, we will categorize the regression as well. Okay? And based on the model as well, that means the function, we will also categorize our regression. Okay? So it is the one of the most basic tools in machine learning for prediction. Now you understood why we are discussing this, because in the data science we already know data science, we have a data points, and what is the goal of data science? We need to estimate or we need to predict some future analysis. Okay. So now coming to now one more thing is that suppose I'm writing this here something. Okay. Hmm. Okay, suppose this is 2011. It is 2014, 2017. It is 2020, and you are having the number of students here. Number of students. Number of students going abroad, and this is year. Okay. So in this year, these are the number of students going in this year, and this year. So suppose you are using the regression analysis and you are trying to estimate the dependent variable, that is the number of students. Clear? So there may be the two cases. Either you are predicting for some internal or for some external. So we can fit a function on the variable, try to predict the outcome for the future or hold output data points. The fitting is two purpose. I am telling you what does do two purpose. First one is the interpolation. you can estimate missing data within your data range. Within your data range. So see, our data range is from 2011 to 2022, and our goal is to predict here question mark question mark, you can say 12 13 15 question mark 16 question mark 18 question mark and 19 question mark. So your goal is to estimate the missing data within your data range. Within your data range. So it is just in category of internal, or you can say interpolation. If you studied mathematics, there is a term that is known as interpolation. Clear? So this is clear what I am trying to say? Yes or no?
Yes, sir.
Okay. Now second category is the external pollution, extrapolation, sorry. So what here it is given that now this time you are having some data points same as above. Students going abroad. Okay, and these are the years 2011, 2012, 2013, and that's 2021. Now for this question mark, for this question mark, for this question mark, and so on. Okay, or before this also is a question mark. Okay, like here question. Okay, so you can estimate the future data outside the data range. Future data outside the data range. So that is called extrapolation. Clear? So that is called extrapolation. So extrapolation is clear. So linear regression can have two scope for estimating the data points within the data range and for estimating outside the data range. Clear? Hello?
Yes, sir.
Clear? So the definition is clear. What is regression analysis? What is the purpose? And we can predict internal points, and we can also predict the external points. That means within the data range and outside the data range. So sometimes in a book you will find that they are telling them for extrapolation purpose or for interpolation. Clear. So just have a 1 minute break and just ask your doubts. Do you have any questions till now?
Sir, can you explain the external integration one more
Yeah.
time?
Yeah. See, we are estimating future data outside the data range. So suppose we are having this example, and in this example we are having number of students. Uh, sorry. We are having number of students that are going abroad for their higher studies, and we are having the data from 2011 to 2021. Okay, and using this data we are going to predict how many students will go abroad in the 2022, 2023, 2024, and then 2025, and so on. So our data range was from 2011 to 2021. We are having the 10 11 years of previous data, and using this previous data we are going to predict how many number of students will go abroad in the future. That means in 2022, 2023, and so on. So this is called extrapolation in term of a linear regression, but this exact definition is not here. Extrapolation आप math में पढ़ेंगे, that is they will explain you in detail in some, ठीक है, but I am just correlating because in the book they just compare regression with the extrapolation, so don't be confused with the book. So that's why I have written in the bracket here. ठीक है, Extrapolation means you are having the data range within some from some in some range, and your goal is to predict for outside the data range. Outside the data range. Clear है?
Yes, sir.
एक one example can I can also give you. Yeah, this is suppose the age, and this is suppose the height. So you are having suppose 1, 2, 3, 4, 5 up to this data point you are having this height. Now your goal is to predict the height for this, predict the height for this, predict and so on. So this is called extrapolation, you can say matlab outside data array. And suppose you are going to predict the how height in between these two, suppose in 1.5 year, then it can comes in the category of interpolation. Clear? So this is inter, this is extrapolation. Okay. Interpolation, extrapolation are mathematics subjects. There is a subject that is called a numerical analysis in mathematics. Mm, so where this is discussed in the detail. Clear? This is clear what is regression. Okay. Okay. Now I'm just discussing one more thing. See, if you remember in the past, I have given you this type of data. Price and square feet area. House data. House data. Do you remember this type of questions?
Yes, sir.
Yeah. Yeah. Just tell me how many features are there.
Sir, the carpet area, the mark,
Yeah.
which it
So
is
we
the
are having the only one feature. We are having only the one feature. So this is called simple linear regression. When we are dealing with only the one feature, when we are dealing with only one features, these are the number of samples. These are the number of samples, or you can say their data samples or data points. Okay? And these are called the features. This is called X value and this is called Y value. This is independent square feet area and the price is the dependent. Clear? So in case of simple linear regression, we only have one feature. We only have one feature and the real data we have more than one features. Clear? So this you can say the dependent. This is you can say the independent. Clear? Okay, so एक minute. I will save these edits. Just a minute. Okay, clear. So the simple linear regression is clear. Now see. Now the same question. Okay, we are having a square feet area. Square feet area. And we can have other data like carpet area. Uh, carpet area or sorry this is suppose square feet area is carpet area, then you can have a build up area, build up area होता है ना, suppose only the one floor is there, so one floor is there, so carpet area and build up area are same. If you are having two floor build, so carpet area is suppose 1,000 square feet, then and two floors are created, so build up area is just double, so the price is also increased. Am I right?
Yes, sir.
है ना? So suppose you are having 1,000 this is and 1,000 this, you are having 1,000 this, but you are having 2,000 this. So this data, ठीक है. One more thing, you can have two washroom, num number of washroom. I will discuss an example in the lab. I have the same data in CSV file, so I will discuss in the lab. Okay. So number of washroom 2, number of washroom is 3, third floor पे also we have created, sorry, in the second floor, and this is, you can say, the price. This we have the price. ठीक है. It is given to us, it is given to us, and again for us. ठीक है. So when we are having more than two feature, then it is called multiple, or you can say the multilinear regression. Clear? Hello?
Yes, sir.
Okay. Now just can you visualize these two? See, I'm trying to visualize. For the previous one, okay, okay, I'm trying to visualize. So for the previous one, you can have this type of line. I'm not exactly, matlab this type of line, matlab you are having data points like this, uh, and I'm just drawing a line. So I'm considering uh, it is a linear. I'm just considering assumptions. This is my assumptions here. Assumptions linear, because in the next page I will discuss linear and polynomials. So I'm just discussing it is linear. Okay. This is my assumptions here. So for this, but for single feature, you can have this is x values, this is y value. So you can visualize this. But for more than two feature, can you visualize it? For three features, sorry, for two features, we can visualize, okay, it is a 3D. Yes or no? So suppose you are having a room, your length is given, width is given. So using the length and width, area is, we can calculate. So for two features, we can have, sorry, it is a three-dimensional. But then if the number of features will increase, then dimensionality will increase. So we are not able to visualize it. Yes or no?
Yes, sir.
Yeah. ठीक है. So this is clear. मतलब what is, if we are having the single feature, then it is called simple. If we are having two or more than two features, then it is called multi regression. Multi regression. ठीक है. So these are the two categories. Now there are some other categories as well. Some other categories as well. Okay. And you will find these type of categories in the books, all of them. Okay. So we are discussing regression now. Now first one is given linear regression. I have given you the example above. So here I'm trying to convince. See, linear regression. What we are assuming here, what we are assuming in case of linear regression, the function that we are going to fit, we are going to fit the data points using the function. So we are assuming there is a linear relationship between the data. Am I right? Yes or no?
Yes, sir.
I can show you the examples. Okay. Sorry, application of data science. Hmm. If you loaded LMS. If you remember, suppose we are having this kind of data, times and concentrations. So we are assuming in the question it is given that linear regression is linear regression will exist, linear relationship will exist. So if our data is such that there follow a linear relationship, there follow a linear relationship, then this regression is called linear regression. Clear? Is it clear?
Yes, sir.
Yes,
Okay, I
sir.
will show you. So can anyone tell me what will be the equation for linear regression? Y is equals to mx plus c. Yes or no? Books में you will find this y equals to alpha plus beta x. In the book you will find this. So we are assuming that our data points will follow this pattern y equals to mx plus c. Obviously there will be some error. This will be not exactly fit linear, but we are assuming that there exists a linear relationship. Clear? So the example that I given you above are for the linear regression, for the linear. Suppose these are the data points and we are predicting this line. We are predicting this line. Clear? So this is clear. What is linear regression?
Yes, sir.
Yeah. Okay. So this linear regression is clear. Okay. And then comes to the polynomial regression. Okay. Lasso has a different formulation. Riz has a different formulation. Logistic has different formulations. So you will be confused अगर मैंने सब mix कर दिया. ठीक है? Because in your syllabus they just only have regression. ठीक है? So now the polynomial. Any example can any one of you can give me? Any example? Any example? Okay, I'm trying to give you. So we do not know whether it is quadratic or it is 3 degree or 4 degree or it is exponential or it is logarithmic. We do not know. So we are assuming that our model will follow this ax to the power n plus bx to the power n minus 1 plus and so on. And we do not know how much n can be 2, n can be 3. Yes or no?
Yes, sir.
So now again, I'm just writing this equation for one variable. I'm writing for the one variable. That means one data, a feature, only one feature. Okay? Only for one feature. So n can be 2 if n is equals to 2, then you are having which for n equals to 2, you are having y equals to ax square plus bx plus c, or you can say you are having a parabola, something like this. Yes or no? It can be matlab, we are not exactly plotting this parabola. You can say this is parabola. uh, Not exactly this. You can have this type of fitting as well. You can have this type of fitting as well. Okay. So suppose your data points is this. So you are having this type of function. Okay. Clear? So what is the linear and what is polynomial regression? Is clear to you? Linear regression can also be for multi data. Polynomial regression can also be for data for data which is having more than two features. Am I right?
Yes, sir.
Okay. So just take a 1 minute break and just ask your doubts. Take a 1 minute break and ask your doubts. No question?
No, sir.
Okay. This last one I can show you in a research paper. Okay. Once you suggested me also show something in research paper as well. So I can show you this in a research paper. Just a minute. I'm trying to show you. देखो, this also mathematical formulation I will show you. Or the mathematical formulation is not there. Just a minute. Okay, here I think mathematical formulation is there. So you can see this loss. So this is the mathematical formulation for Lasso problem. Clear? So I'm just trying to show you in the research what you are going to study. All the things can be used in the research as well. Clear?
Yes, sir.
So this is the Lasso formulation. Okay. Okay. So we were here. Yeah. So this is clear. Linear. Now logistic regression. What happened? We also have a different kind of functions in logistic regression as well. Okay. In the regression as well, we have different kind of formulation. Also, I have shown you. Okay. And logistic, I will check. I think it is not in your syllabus. So what happened in the logistic? Instead of predicting a real value output in the logistic, we will predict the output in the range of from 0 to 1. Okay. So in the above one, we were predicting the y values in a real, these are the real values. They can have anything from minus infinity to plus infinity. But in case of logistic, our goal is to transform them in the range of 0 to 1. So for that, there is a different kind of function is there. Okay. But if I will discuss this, you will be confused. मतलब सब mix हो जाएगा. Clear? So this is clear. Regression. If you are having one feature, it is called simple. If you are having two or more than two feature, it is called regression. Multi-regression. Okay? Linear regression. If you are assuming that there is a linear relationship between the dependent and the independent variables. So it is called linear regression. If there is a no linear relationship, there can be polynomial, maybe parabolic, or maybe 3-degree curve they can follow, or they can follow anything else. Okay? So it is called polynomial regression. Clear? Yes or no?
Yes.
If
Yes.
it is clear, yes.
Yes, sir.
Okay.
Clear.
Now I will show you the mathematically. See. So now what happened is that what is the goal? Our goal is see, we were having some data points. Suppose we are considering only one feature. Okay? So we are considering only one feature right now. We are having x1, y1, x2, y2, and so on. Okay? X n, y n. Okay? We are having n data points and data points. Okay? Using these data points, what is our goal? Our goal is to estimate a function. Estimate a function. So in case of linear, the function was y equals to mx plus c. So you can say our f of x p is equals to mx plus c for linear. Keep in mind, I'm telling you for linear. It is not for general purpose. Okay? So for estimating a function f of p, p means parameters. In case of this, what are parameters? Parameters are m and c. M and C are the parameters which are unknown. Okay? So using these parameters, our goal is to estimate a function. Okay? Estimate a function, and using this function, what we will do? For some points, like you can have n plus 1, you can have n plus 2, and this is question mark, this is question mark. So now using this function f of p and this data points x values, independent variables, our goal is to predict the dependent variable. ठीक है? अब इस function को how we will estimate this function? We will assume some loss. ठीक है? I will tell you कैसे. See, so just tell me one thing. See, you are estimating this function. ठीक है? आपके data point suppose this thing, or you are estimated this line. So there may be some error. There must be some error. Yes or no? Am I right?
Sir, can you repeat just last point?
What I am saying is that we are having x values and y values. Using these x and y values, we are estimating a function. We are estimating a function. Okay? So what is the goal of this function? Using this function, we are going to predict the y values for x values. Okay? So our goal is to estimate a function. Okay? Now for linear regression, our function is y equals to mx plus c. Y equals to mx plus c, and where m and c are the parameters that we are going to calculate. Now how we will calculate these parameters? How we will calculate these parameters? Okay, just tell me. See, for x1 y1 is given, for x2 y2 is given, up to for xn yn is given. Okay? These are called the actual values, y1 to yn. Yes or no?
Yes, sir.
These are the actual values. Now using this function y equals to mx plus c, we are also obtaining y values. Yes or no?
Yes, sir.
So this is called predicted. I think यहाँ पे cap use, we can use cap for differences. So this is called predicted. So this one is your this one, and this one is the actual one. ठीक है? So there must be some error, may or may not, not must. There may or may not some error. Am I right?
Yes, sir.
Yeah. So how we will estimate this MNC? We will estimate MNC such that this error will be minimum. This error will be minimum. So this is called loss function. ठीक है? So this is called loss. Loss क्या होता है? We are having some function between our predicted value. इसको L नाम दे देते हैं F की जगह, just a minute. Yeah, so we will give this L. What will be this function? This function is our F, and actual value. What are the actual values? Y, yi, for I equals to 1 to n. Am I right? This L is what? L is the loss, or you can see the error between actual y and the predicted y. Clear?
Sir, the value of actual y would be from coming from the graph, and the
The
predicted value would.
actual value of y are given to us,
Okay, sir.
and the predicted value of y that we are obtaining from y equals to mx plus c. So we are assuming this linear graph, or you can say the line, sorry, this line. So these are the predicted y's value. And these points, data points that are given to us are called the actual y values. And the difference between them is called the error. Clear?
Sir, can you explain this with an example as well?
Yes, okay. I will going to prove this actually. मैं इसको prove करूंगा.
Okay, sir.
ठीक है, आई विल ड्राइव द फॉर्मूला एज वेल. ठीक है, एग्जाम्पल से ओके वी कैन डू एग्जाम्पल एज वेल, बट आई विल प्रूव दिस, मतलब कि आई विल शो यू दिस. ठीक है, सो सी मैं यहाँ पे प्रूविंग कर रहा था फॉर हैंड रिटन नोट्स. ओके, सी सो व्हाट हैपेंड इन दिस केस. So linear regression, yeah, so we are discussing linear regression here. ठीक है, clear? We are discussing linear regression. That means we are assuming the estimated function is linear. ठीक है, and we are assuming only one data point. That means line or 2D data point. ठीक है, so I am proving this. Can we move further?
Yes, sir.
Okay, ठीक है. So what now? What I told you, I will discuss what I have written here. So what I told you, our goal is to estimate M and C. Our goal is to estimate M and C. Okay, how we are going to estimate? We are having Y predicted values. We are having Y predicted values. We are having Y actual values. Clear? What we are going to do? We are minimizing the sum of square. Or this is called mean square error. Minimizing. Clear? So we are going to minimize this function to calculate M and C. If you remember in the first class, I can show you the example here. Okay, no problem. So if you remember in the first class, I have given you this data, and I ask you this. The doctor may wish to estimate the concentration of a blood in 3.5 year. If I can dictate this question again. So a patient is given a drip feed containing a particular chemical and its concentration in the blood. Okay, so this is the time interval. That means initially the concentration is this, after 1 hour the concentration is this, after 2 hour concentration is this, after 3 hour concentration is this. So we are having this data. Okay, in this data concentration is the dependent variable. Okay, because it depends on the time. ठीक है, and time is the independent variable, and it is assuming that there is a linear relationship. उनके बीच में क्या था? There is a linear relationship. So the doctor may wish to estimate the concentration in the blood in 3.5 year. In between this we need to obtain the concentration. ठीक है, clear friends?
Yes, sir.
Yes,
ठीक है.
sir.
Yeah. Solution I need to prove this, but I can show you the directly here as well. ठीक है. So this is the question. If you remember, solution is okay. This is the solution here. So the solution is this. I am directly showing you the solution. Okay. So we were having this uh, alpha beta here. Okay. Alpha is C, and because in the book they have given alpha and beta. So this is C and this is M. I am going to prove this actually. I do not want to remember actually. Matlab you need to remember, but you should know how mathematically it drives. Okay. So see. So we have calculated alpha and beta, and using that alpha beta, I have calculated the concentration at 3.5. Okay, 3.5. Clear? So up now, if you want to see this error, what I can do is see question. Where is question? Uh, okay, this is the question here. Okay, so see in 3 for 3 for 3 concentration is 6.9. Am I right? Yes or no?
Yes, sir.
अरे आपकी क्लास का टाइमिंग क्या है? 10:30 11:45 होगा आई थिंक, है ना?
Sir, 11:35 है.
ओ सॉरी 35, सॉरी. ठीक है. नाउ यूजिंग द फॉर्मूला व्हाट वी हैव कैलकुलेटेड अल्फा बीटा. ठीक है. सो वी हैव कैलकुलेटेड दिस अल्फा 2.56 and 1.65. Okay. Sorry. Luckily, I have example prepared. Alpha is equals to 2.56 और बीटा क्या था? 1.65. Beta equals to 1.65. Now using this alpha beta, what will be your y? Alpha plus beta x. Alpha is 2.56. Beta is 1.65 into x is how much? 3. इसको calculate कीजिए fast. Please. Okay, I'm calculating. 2.56 plus 1.65 into 3. It is 7.5.
7.51.
7.5. Actually, it is 6.9, but now predicted is 7. So this is called error in our data, our estimation. Now it is clear.
Yes, sir.
Okay. So luckily, I have I had solved example, so it saved my time actually. Okay. Otherwise, I need to solve it again and drive. Clear. So this I was going to, so I will show you the formula that I used for calculating M and C, or you can say alpha and beta according to the books. So in the next class, I will show you this proving here. Okay. And after that onward, I will show you only for linear for one feature only, because for multi feature, it is mathematically very difficult to drive each formulas. Okay, so in the lab we will discuss the example, and then in the next lab class we will discuss the derivation. Do you want to see mathematics, or I can just write the formula here? Which one is good for you?
Sir, like proving the functions, like how.
You're proving the alpha, proving the calculation of alpha and beta, or you can say M and C. Do you want to see that proving how we calculated M and C, or you just need final answer? This is the formula for M, this is the formula for C.
Sir, that proving would be for knowledge only, right?
Yeah, proving will be only for the knowledge, and it will also, suppose you are going for higher study, so you just need to know the background. Matlab, suppose someone asks you in the interview, so how you will calculate this MNC? Matlab, what is the mathematics? You just know the programming, matlab, Python library, or you know internally how this work.
Okay, sir.
This
Sir,
is the purpose here.
see the proof as well.
Yeah. Okay, so in the next I will show you. Clear? So anything you want to ask? I
Sir,
have actually
the
another class.
question sheet and the answer that you was just showing to us, can you